In this video, I'm going to be looking at the sine and cosine rule as well as trigonometry to find areas of triangles. Now, what do these rules do? Well, essentially the sine and cosine rule allow you to find angles and sides in non-right angle triangles. With Pythagoras, we've been looking at right angle triangles. It allows us to find the sides of the triangle, whereas with trigonometry, so SOHCAHTOA, we can use that to find also angles. Now, this is an upgrade. Essentially, what it does, it allows us to find the lengths and lengths of sides and the angles within non-right angle triangles. Now, the first rule we're going to be looking at is the sine rule. Now, the sine rule is sine A over A is equal to sine B over B. Now, what's going on here? The capital letters always refer to angles. So I could say that this is one of my angles, and the small letters refer to their opposite side. So A and then small a, okay? Now, the B, again, this is an angle here, and this will be its opposite side. And if we wanted to include the C in this one here as well, this would be capital C and small c there, okay? So the first thing to do is to label your triangles so that you can actually do the you can actually use the equation. Now the hard part for these is working out which rule you should use when. Now, let me show you this. What's going on with the sine rule is what you'll do is you'll have an angle with an opposite side, and in the same way you'll also have an angle with an opposite side. Now there are 4 values here. One of them will be an unknown. So you need to have 3. At least, yeah, so you essentially have to have 3 before you can work out what the 4th one is. Now, this sine rule can actually be written as sine A over small a is equal to sine B over small b, but it can also be written as A over sine A is equal to B over sine B. Now, occasionally you'll also see sine C over C here, but essentially what we just need this first part here for these. So what I'm going to do now is I've got those here. I've got my small a, and that is 12, okay? And I've also got its opposite side, its opposite angle, which is 40. Now also we've got this b here, which I'm going to call x, and we've also got its opposite angle there, which is 30. Now, what I've done is I've put the unknown at the top. Okay, I put the x on the top, and this makes it much easier to solve. Now, of course, in this equation up at the top here, if you're trying to find an angle, it makes it easier if you have the angle on the top, but I've just put that on the top there. Now, get into the habit of that and makes things a lot easier. Now, in order to solve this, all we have to do is times both sides by sine 30, and that will get rid of that sine 30 on the bottom there. Okay, so what we end up with is, here we go, is 12 sine 30, because we're timesing it by that, over sine 40 is equal to x. And then all I have to do is pop that into the calculator. So I just press my fraction button, and then 12 sine 30 over sine 40. In some calculators, you might need to put the times there between the 12 sine 30, and the calculator will automatically put brackets for you. When I put that into the calculator, my answer is 9.33434 ... which I then can round to 9.33 to 3 significant figures. And that has told me that this side here, okay, this side here is 9.33. Now, the next thing I do is actually look at the actual triangle, and I think to myself, well, that's 9, and the opposite is, this angle here is 12. That's not outside, the realms of possibility here. But say, for example, my side was 5,000, then it might be a little bit strange. So, okay, so that's how to do the sine rule. Now, what I'm going to do is next to it, I'll do the cosine rule so we can see the difference between the two of them, and then I'll do another example of each. Okay, now the cosine rule is slightly different. It is this. So the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. Okay, so that's the cosine rule there. Now, what's happening? Let me underline those. So we've got our a here on its own, okay, and that is a side. B and C are both sides as well because they're small letters, and B and C are there again. But this capital A is an angle. Now what we're going to do is I'm going to circle this angle here. The angle here is 60. That's the only angle we've got. So I'm going to name that angle A. Its opposite side, remember they're always labeled opposites, so the opposite side to this angle will be small a, and then these two sides can be B and C. It doesn't actually matter which one they are because you're going to be adding them and then multiplying them, so it doesn't actually matter which order you do them in. But here's my big C and here's my big B here. The most important thing is that you're labeling your A, small a, B and C. Okay, so now I've got these values. Have a look at the pattern. Now what's actually happening here is I have these three here. They all belong, they're all essentially on the same side, as you can see, and they sort of ganging up on this A on the opposite side here. Okay, now sometimes I kind of call this the sort of Pac-Man rule. Essentially, it's opposite to the A. There we have a side, a B and a C, and your big A like this within the triangle. Okay, so now mine's obviously not looking a huge amount like a Pac-Man there, but that's absolutely fine. Right, so let's put those values in. So my A squared, I don't know, is my X squared. My B squared here will be 8 squared. My C is 10, so that's 10 squared, minus 2 lots of 8 times 10 times by cos 60. Okay, now very often I think it's useful to put brackets around this entire part here because some people end up simplifying this first part and forget that there is a multiplication here between the cos 60. So let me actually put that into my calculator. Well, I can do this first. So that's 64 plus 100 minus 160 times cos 60. Now if I pop that into my calculator, I'm going to get 64 plus 100 minus 160 times by cos 60. I'm going to close my brackets, and the answer is 84, meaning that my, there we go. And if I want to get my x, all I have to do is square root the 84. Okay, so I'm just square root my answer, and the answer there is x is equal to 9.16515 ... So that rounds to 9.17 to 3 significant figures. So again, now I have a look at this and I can see that 9.17 is it's sort of in line with this 8 and this 10, so it's not ridiculous. It's not like 200 or something like that. Okay. Now let's quickly recap. So what we've got is the sine rule here. Essentially, you can see that we've got these kind of opposites. I'm drawing all over these. We've got these opposites, whereas with the cosine rule, we can see we've sort of got these three together, and they're ganging up on this opposite side here. But let's go through another example. Now, this is another example of the sine rule, and except in this one, instead of using the instead of working out a side, we're going to be working out an angle. So have a look at this. We can see that there are opposites here. Okay, that gives us our opposites. And again, what I said just a little bit earlier is I want to have my unknown on the top, so I'm going to use sine A over A is equal to sine B over B. That's because it's an angle that I'm trying to work out, so I make sure my angle is on top. Okay, right, so now let's pop those in. So I've got sine x over, now again, what I'm going to do is I'm going to call that one A and this one little a, and this one here B and little b there. Again, labeling makes things a lot easier. And make sure you're labeling the opposites. So that is, and it's over 20, is the same as sine B, which is sine 35 over 15. Again, what I'm doing there is I'm just going to solve this now here. So what I'm going to do is I'm going to times both sides by 20 to get rid of this 20 here. So I've got sine x is the same as 20 times sine 35 all over 15. Okay, now obviously it could just be written as, sorry, here we go. It could just be written as 20 times by sine 35 over 15, but that is the same thing. Okay, so, right, good. Now I pop that into my calculator. So I'm going to put my fraction button, and 20, remember some calculators need you to put times by sine 35, close my brackets, and then all over 15. And that gives us a sine x is equal to 0.76476 ... So how do we get the x on its own? Well, what we do is we do sine to the minus 1 of both sides. So what we then do is I'm going to press shift sine and then put my answer in there. And the answer here that I've got on my calculator is 49.886 ... So x is equal to 49.9 degrees to 3 significant figures there. So again, I have these opposites. Okay, so I pop them into my sine rule here, which you do need to memorize, and there you got the answer. Okay, now let's have a look again. What we've got here is another cosine rule, and the way I recognize it here is I've got two sides and an angle here. Okay, and I've got my angle here. So these guys, okay, are ganging up on the opposite side there. Now, in this case, it's slightly different. So remember, here we go. So we've got our cosine rule is a squared equals b squared plus c squared minus 2bc cos a. But for this question, we're going to actually be working out cos a. We're going to be working out the angle. So it's useful to also know that there is a rearrangement of this where I can take the 2bc cos a over to this side and take the a squared over there. So I've got my 2bc cos a is the same as b squared plus c squared minus a squared. And then to get my cos a on its own, I've got b squared plus c squared minus a squared all over 2bc. And in this case, what we've got is, let's label them, I've got my a, because that's my only angle that I have, and this will be my b and my c here, and this will be my small a, and I can now substitute into this equation. So cos x will equal to my b squared, which is 10 squared, plus my c squared. Now remember, the 10 and the 12 can be interchangeable. It doesn't matter which one's the b or the c, but it does matter which one the a is, which is my a squared over 2 lots of 10 times 12 there. So if I pop that into my calculator, I actually get cos x is equal to 3 over 4. And if I want to get the x on its own, I cos to the minus 1 both sides there. Of 3 over 4. So if I do shift cos and then I do my 3 over 4, the answer there is x is equal to 41.4096 ... So x would be 41.4 degrees to 3 significant figures. Now, the last rule to look at is areas of triangles where they're not right angles, or we don't know the height. Now, the equation for the area is area equals half AB sine big C. Okay, half absence. That's how many people remember it. Now, have a look at this. We have a large C, so this is our angle, and the only angle we have is this one here. And we have our A and our B here. So this is our A and our B. And of course, this would be small c, and this would be big A, and this would be big B here, because they're on opposites. But we only need our A and our B and the angle. So the way you remember it is that it is just the two sides, either side of an angle, and that will allow you to find the area of this shape here. So let's have a look at this one. We've got, so the area of this shape would be given by a half times A, in this case is 8, and the B is 10, times by sine of the angle, which is 30. So I pop that into my calculator, and the answer I've got here is 20. And because the units are meters, I need to make sure 20 meters squared here if you put those into the calculator. It's actually pretty straightforward. The hardest part really is just remembering the equation, and also remembering that the big C will be your angle, and then the A and the B will be your two sides. Now what happens if we don't know the angle some questions, they'll actually give us the area, and they'll ask us to find the angle. So what we do again is area is equal to half absence, or half AB sine C, and then we plug our values in there. But we're told in this question the area is 106, so we can put 106 as our area is equal to half times A times B times sine of the angle. Now, which ones are our A's and our B's? Again, same thing. We label the C. This is our the big C is our angle, meaning that would be little c there. And this would be our A and our B. Now, again, it doesn't matter which one is the A and which one's the B, because, again, they're just going to be multiplied. So, in this case, I've got my 15 and I've got my 20 in this order. So, 106 is equal to 150 times by sine x. Now, I can divide both sides by 150. So 106 divided by 150 will be the same as sine x, or equal to sine x. And then all I have to do is the 106 divided by the 150. And then I do, there we go, this is the rule here. We do sine to the minus 1 of both sides so that we get the x on its own. And sine to the minus 1, so shift sine of 106 divided by 150, close brackets, gives me 44.964 dot dot dot. And so I know that my x here is 44.9 to 3 significant figures, and that is the degrees there. So just to recap for the area, what you will have is you'll have an angle with two sides either side of it, these little buddies, and you use this equation here. Same thing again. I've got my angle here with these either side will give me my area. So it's much like the sort of the cosine rule with those three together. Now, what can sometimes happen with questions is you might be given one of these other angles here. Okay, so you might be given something like this angle here, and you may also be given this angle here, and therefore you want to work out which is the angle in between. So how we can make these questions difficult, or how they can make them difficult in an exam, is that you have to actually end up finding these two sides with their angle between the two of them.